Okay, just a very quick overview that what you're going to be looking at in Chapter 12 of Comparing Multiple Proportions, Test of Independence, and Goodness of Fit Test. So we're going to be looking at these three items here, okay, topics, that when you complete this week's material, you'll be able to understand how to test for three or more population proportions, hypothesis testing, of course, test of independence, and then goodness of fit test. When we look at testing proportions, this is going back to hypothesis testing, but now because we have additional, looking at three or more proportions, this is going to be based on the chi-square distribution. And in all cases, our data is going to be categorical. All right, so in other words, we might have, 3, 4, 5 different population proportions that we want to test. And we want to test to see with our null hypothesis that they're equal, with our alternative hypothesis that not all proportions are actually equal. And so if the null cannot be rejected, then we cannot detect that there's actually any differences. If it is rejected, then we can conclude not all are equal, and then we could do further analysis to figure out which proportions were not the same as the others. I walk you through an example of how to do this in Blackboard, so be sure and look at the customer satisfaction survey. This is on the cars, the Chevy, Honda, Ford. All right. And as I mentioned, this is a chi-square test statistic. So you're going to see all of these are going to kind of look the same. It's just how you set up your hypothesis and come up with your results, where this first value is what we actually observe and then minus what we would expect. And the I sub j's have to do with what row and column that they're in. Okay, so remember, this is a chi-square, not a z. If you've come out of, stats 1 and not a t, this is a chi-squared distribution, and with k minus 1 degrees of freedom, with k being your number of categories. And of course, as you learned from stats 1, hopefully, if you're looking at a p-value, you reject the null if the p is low. Remember that, if your p-value is less than alpha, or some prefer the critical value approach where you would reject your null if your test statistic, okay, is greater than your actual critical value. All right, and then next you'll do test of independence, where again, this is going to be a chi-square. The formulas, when you set up your chi-square, is going to look the same. But now what we're wanting to do is test to say that a column variable is independent of a particular row. So we have to compute these actual expected values. Okay, and then we're going to end up using the same formula, but we need to compute the expected values. And then notice the test statistic looks exactly the same, all right, as the last one. And then, of course, we have the same thing where we reject the null if the p is low or if our test statistic is greater than our critical value. Be careful with the degrees of freedom, okay, with n minus 1, your rows minus 1, times your columns minus 1. And I do have an example of a test of independence in Blackboard where the columns are the music preference and the rows are actually where some individual lives, to see if it's independent of where they live, if they have a preference to a certain type of music. And then you'll finish up with the goodness of fit. We're going to only look at the normal distribution. So we're going to use a chi-square distribution. Now this one's going to be a little weird, so you definitely want to go through my video, because in the video I show you how to set up a particular number of categories, so you're going to have to do that on your own. So be sure and watch that video before you get started on the assignment.